In the vast expanse of international waters, a force to be reckoned with is silently patrolling. We're talking about the Gerald R. Ford-class aircraft carrier, a floating fortress that has left nations like Hamas, Iran, Russia, and China taking notice. This behemoth of the seas represents a quantum leap in naval technology, packed with cutting-edge features that redefine what a modern aircraft carrier is capable of. From its advanced electromagnetic catapult system to its state-of-the-art defense systems, every inch of this carrier screams power and precision. But why are countries like Iran, Russia, and China closely monitoring its movements? What makes this carrier such a game-changer in the geopolitical landscape? Today, we're going to uncover the secrets, the technology, and the strategic implications of the Gerald R. Ford-class aircraft carrier. So stay tuned as we embark on this fascinating journey into the heart of modern naval warfare. Gerald R. Ford-class aircraft carrier. The Gerald R. Ford class is all about replacing the existing Enterprise and Nimitz-class carriers. The very first of these, the USS Gerald R. Ford, CVN-78, was ordered from Newport News Shipbuilding back in 2008 and was expected to set sail by 2016. This new class of carriers is designed to be the Navy's premier forward asset for crisis response and early decisive striking power in major combat operations. It's all about being where it's needed, when it's needed, with overwhelming force. But what sets these carriers apart? Well, the Gerald R. Ford class carriers and their strike groups will provide essential capabilities like forward presence, deterrence, sea control, power projection, maritime security, and humanitarian assistance. This isn't just about might. It's also about being a force for good in the world. The key to these carriers is the improved warfighting capability, making them more effective in any combat situation. Plus, there are quality of life improvements for our brave sailors who serve on board, ensuring they have the best possible working conditions. And to top it off, these carriers are designed to reduce total ownership costs, making them not just powerful, but also cost-effective. Now, what makes these ships stand out even more is their nuclear power. They're part of the next generation of nuclear-powered aircraft carriers, which means they can stay at sea for extended periods without refueling. The US Navy plans to acquire 10 of these incredible ships, replacing the existing carriers one by one. The first in the class, the USS Gerald R. Ford, CVN-78, already commissioned in 2017, replaced the USS Enterprise. And we can look forward to the USS John F. Kennedy, CVN-79, the second ship of the class, joining the fleet in 2025. These carriers feature advanced technology, like the electromagnetic aircraft launch system, EMALS. That means more efficient aircraft launches and recoveries, giving these carriers a tactical edge. They also come with various design features aimed at boosting efficiency and lowering operating costs. And let's not forget, they can sail with smaller crews, showing that technology is not just about power, but also about smarter ways of doing things. And one more thing that's worth mentioning, these magnificent vessels are named after a former US President, Gerald R. Ford. It's a testament to the enduring legacy of leaders who have shaped the nation. So, in a nutshell, the Gerald R. Ford class carriers are setting new standards in naval power projection. With their cutting-edge technology, enhanced capabilities, and commitment to making the world a better place, they're not just carriers. They're a symbol of American ingenuity and strength. Development. You might be familiar with the Nimitz-class carriers that have been the backbone of US naval power for decades. These massive vessels, like the USS Theodore Roosevelt, have showcased incredible endurance, cruising for up to 90 days without resupply. However, as time went on, it became clear that the Nimitz design had its limits. It struggled to keep up with the latest technological advances due to constraints in power generation and increased ship weight. That's where the CVN-21 program, now known as the Gerald R. Ford class, steps in. So, what sets the Ford class apart? Well, let's start with the basics. These carriers boast a larger flight deck, better weapons handling, and a redesigned propulsion plant that requires fewer personnel to operate and maintain. The island, the iconic structure on the carrier's flight deck, has been repositioned to improve efficiency. But that's not all. There have been remarkable strides in technology. Ever heard of the electromagnetic aircraft launch system? emails, and advanced arresting gear, AAG. These cutting-edge systems have revolutionized how aircraft are launched and recovered on these carriers. Here's the real game changer, the Ship Self-Defense System, SSDS. It's an integrated warfare system that enhances the carrier's ability to adapt to new missions seamlessly. And let's not forget about the dual-band radar, DBR, which combines both S-band and X-band radar for heightened situational awareness. All these advancements mean one thing. The Gerald R. Ford-class carriers can launch a staggering 25% more sorties, generate triple the electrical power with improved efficiency, and offer significant improvements in crew quality of life. This is a leap forward in naval technology and a testament to the continuous pursuit of excellence. Flight deck. You see, on the older Nimitz-class carriers, there was a significant limitation. Catapult No. 4 couldn't launch fully loaded aircraft due to low wing clearance along the edge of the flight deck. This might not sound like a big deal, but it actually is. It meant that some aircraft had to take off with reduced fuel and weapons, limiting their capabilities. But the Gerald R. Ford-class carriers have addressed this issue. They've upped their game and redesigned the catapult system. These new catapults are more efficient and have higher wing clearance, allowing them to launch fully loaded aircraft with ease. This upgrade significantly boosts the carrier's overall combat readiness, giving it the ability to respond swiftly and effectively in any situation. Now let's talk about how the Ford-class carriers have revolutionized the handling of ordnance. Ordnance, which includes weapons and ammunition, plays a crucial role in any naval operation. On older carriers, the process of moving these munitions from storage to the aircraft on the flight deck used to be a time-consuming and complex task. But here's where the Ford-class carriers step in with innovation. They've streamlined and accelerated this process. They've introduced high-capacity weapons elevators that use linear motors. These elevators can transport ordnance quickly and efficiently to a centralized rearming location. What's remarkable is that these elevators are strategically located so that ordnance doesn't cross any areas of aircraft movement. This means fewer traffic problems in the hangars and on the flight deck, making the entire process smoother and faster. In fact, Rear Admiral Dennis M. Dwyer once mentioned that these changes could potentially allow for rearming the airplanes in a matter of minutes instead of hours. Now, that's a game changer when it comes to quick response and operational efficiency. Power generation. Unlike their predecessors, the Nimitz-class carriers, the A-1B reactor is not only smaller and simpler, but also requires fewer crew members to operate. Yet, don't let that fool you. It packs a serious punch in terms of power. In fact, each Gerald R. Ford-class carrier is equipped with 2 of these reactors, boasting a power generation capacity that's at least 25% greater than the 550 MW produced by the 2 A4W reactors on a Nimitz-class carrier. But here's the real game changer, a whopping 3-fold increase in the portion of thermal power allocated for electrical generation. This means more juice for the ship's systems, and especially for those cutting-edge electromagnetic catapults. Now, you might be wondering why this upgrade was necessary. Well, it all comes down to the evolving technology on board. You see, the Nimitz-class carriers were designed back in the 1960s, a time when onboard tech demanded far less electrical power. Fast forward to today, and we've added so many new technologies that the old power systems were struggling to keep up. That's where the Gerald R. Ford class steps in. Steam, the age-old power source, is converted into electricity using 4 main turbine generators, which in turn fuel the ship's major systems. And let's not forget, they're also the driving force behind those revolutionary electromagnetic catapults. The Navy's engineers had the foresight to design these carriers with the future in mind. They knew that technology would continue to advance, so they built in extra capacity. The Navy envisions these Ford-class carriers serving in the fleet for a staggering 90 years, all the way up until 2105. That's a century of potential technological evolution. Currently, only half of the electric power generation capacity is utilized by planned systems, leaving the other half wide open for whatever the future holds. Electromagnetic Aircraft Launch System. Unlike the traditional steam catapult used on the older Nimitz-class carriers, the Gerald R. Ford class boasts an electromagnetic catapult system. But what's the big deal? Well, here's the magic. Emails uses a linear induction motor to launch aircraft. This linear motor technology offers a smoother acceleration for the aircraft. It's like a high-tech roller coaster, but for fighter jets. The gentle push provided by emails puts significantly less stress on the airframes of the aircraft being launched, making them last longer and perform better. Emails is lighter than the old steam catapults. That's right, it's not only cutting edge but also more efficient. The reduced weight means the carrier can carry more payload without overloading itself. Plus, it's expected to be cost-effective in the long run, requiring less maintenance and repairs. Who doesn't love cost savings? Emails isn't just a one-trick pony. It's incredibly versatile. It can launch a wide range of aircraft, from the heavier, more powerful jets to the lighter, agile ones. This flexibility gives the Navy more options in terms of aircraft selection and mission capabilities. Emails also comes with environmental perks. It reduces the carrier's demand for fresh water. You see, steam catapults required a significant amount of water for operation, which meant carriers had to carry large water supplies or invest in energy-intensive desalination processes. With emails, that's no longer a pressing concern, helping reduce the carrier's environmental footprint. Sensors and self-defense systems. One standout feature is the integrated dual-band radar, developed by Raytheon. It combines an X-band radar for low-altitude tracking with an S-band volume search radar for target search and tracking in any weather. What's impressive is how it uses 3-phased arrays for each band, all in one 6-phased radar. This means more capability in a smaller space. No moving parts. That means less maintenance and fewer personnel needed to keep it running. The system is split between above-deck REX cabinets and below-deck SDP subsystems. And for the first time, the DBR uses a central controller to manage 2 active array radars operating at different frequencies, revolutionizing radar technology. Powering this beast is the Common Array Power System, with power conversion and distribution units, and it's kept cool by the Common Array Cooling System. Now, in the upcoming John F. Kennedy carrier, we'll see the Enterprise Air Surveillance Radar, a sleek new design that comes at a lower cost compared to the DBR. So, the Gerald R. Ford-class carriers aren't just massive, they're loaded with state-of-the-art sensor systems that redefine naval capabilities. Possible upgrades. The Ford-class carriers are gearing up for the future with advanced defense systems like free electron laser directed energy weapons and electric armor. Now, here's the kicker. Only half of the electrical power generation capability on CVN-78 is needed to run the current systems, including the electromagnetic aircraft launch system, emails. This means CVN-78 has power reserves, something the older Nimitz-class carriers lacked, to power up lasers and electric armor. Talk about a game changer. These upgrades also mean a whopping 25% increase in sortie rate compared to the Nimitz class. That's more missions and more firepower. And here's the best part. A 25% reduction in manpower needed to operate. That means a leaner, meaner, and more efficient fighting force. Now, let's talk about something you might not expect on a warship: waste management. The Gerald R. Ford class is equipped with state-of-the-art waste disposal tech. Developed in partnership with the Carderock Division of the Naval Surface Warfare Center and Pyrogenesis Canada Inc., they've rolled out the Plasma Arc Waste Destruction System, PAWDs. This compact marvel takes care of all the combustible solid waste generated on board the ship. It's a significant step forward in sustainability and efficiency. And finally, let's touch on defense. The Navy is pushing boundaries with the development of a free electron laser, FEL. This bad boy is designed to defend against cruise missiles and small boat swarms. It's a high-tech shield that's going to make a big difference in the carrier's defensive capabilities. 3D computer-aided design. Newport News Shipbuilding, the powerhouse behind the Gerald R. Ford class, employed a groundbreaking tool in their arsenal, a full-scale 3-dimensional product model developed in Dassault Systèmes' CATIA V5. This software allowed them to bring to life every inch of this awe-inspiring vessel, ensuring that every component was meticulously designed and flawlessly integrated. Now let's talk about some of the incredible features designed with meticulous precision. One standout improvement is the reimagining of weapons movement paths within the ship. This means that unnecessary horizontal movements have been significantly reduced, streamlining operations and enhancing overall efficiency. advanced weapons elevators have been strategically positioned to seamlessly transport armaments from storage areas to dedicated weapons handling zones. Imagine sailors using motorized carts to effortlessly navigate these elevators at different levels of the weapons magazines. Linear motors are even being considered for these advanced weapons elevators, further pushing the boundaries of technological innovation. This means faster and more efficient movements, ensuring that our carriers are always ready for action. The redesign of these weapons movement paths, along with the repositioning of the elevators on the flight deck, is a game changer. It not only reduces the manpower needed for operations, but also contributes to a significantly higher sortie generation rate. That means more missions accomplished in less time. Planned Aircraft Complement. The Gerald R. Ford class is a cutting-edge series of aircraft carriers designed to house a remarkable piece of military technology, the F-35C, the carrier variant of the Joint Strike Fighter. Sounds impressive, right? Well, it is. But there's a bit of a twist to this story. You see, integrating the F-35C onto the Gerald R. Ford CVN-78 has faced its fair share of challenges. The F-35C, with its next-level capabilities, had to undergo rigorous testing with the ship's cutting-edge systems, like the electromagnetic aircraft launch system, emails, and the advanced arresting gear. They also had to ensure that the carrier could safely store the F-35C's high-tech lithium-ion batteries, tires, and wheels. It's a bit like fitting a square peg into a round hole, but with a lot more technology involved. Here's the kicker. Developmental delays with the F-35C meant the US Navy couldn't get its hands on these incredible aircraft until at least 2018, a whole year after CVN-78 was delivered. You might be wondering why this matters, right? Well, this delay created a bit of a hiccup in the grand plan. With the F-35C integration pushed back, the Navy had to defer some crucial activities. This introduces a risk of system incompatibilities and the possibility of costly retrofits to the ship after it's already in service. Imagine buying a brand new car and having to make expensive modifications right after driving it off the lot. Not ideal. Construction. The journey of the Gerald R. Ford class began officially on August 11, 2005, when Northrop Grumman kicked things off with a ceremonial steel cut for a 15-ton plate that would eventually become part of the carrier's side shell. But the real action started in early 2007, and the carrier took shape at Newport News Shipbuilding, which is a part of Huntington Ingalls Industries, located in Newport News, Virginia. What makes this shipyard special is that it's the only place in the United States capable of constructing these nuclear-powered aircraft carriers. The price tag for the Gerald R. Ford class was initially estimated at around $13 billion, with $5 billion allocated for research and development and another $8 billion for actual construction. Fast forward to 2009, and the estimate climbed to $14 billion, including $9 billion for construction. A considerable investment, but you'll soon see why. Originally, 3 carriers were authorized for construction, but there's a more significant plan at play here. You see, the Nimitz-class carriers and the USS Enterprise needed replacing, and to maintain a one-for-one replacement, a whopping 11 carriers would be needed over the program's lifespan. The last Nimitz-class carrier is scheduled for decommissioning in 2058, which means we're in it for the long haul. In 2009, Secretary of Defense Robert Gates announced a 5-year construction schedule for each Gerald R. Ford-class carrier, creating a sustainable path towards a 10-carrier fleet after 2040. But plans changed in December 2016 when Navy Secretary Ray Mabus signed a force structure assessment, pushing for a 355-ship fleet with 12 aircraft carriers. If that's the case, it would require each Gerald R. Ford-class carrier to be constructed in just 3 to 4 years. As if the massive scale and evolving strategy weren't enough, the shipbuilder introduced some first-of-class type design changes while constructing CVN-78. These changes are being used to update the model for future vessels in the class. Many of these adjustments are related to the emails, electromagnetic aircraft launch system configuration, which required rewiring and other modifications within the ship. The Navy expects more design changes in the future, stemming from advanced arresting gear development and testing. And get this, over 19,000 changes were incorporated into the construction schedule, thanks to the government's decision to integrate improvements to the ship's warfare systems during construction. So there you have it, the incredible journey of constructing the Gerald R. Ford-class aircraft carriers. The innovative technology, strategic shifts, and the sheer scale of these vessels are mind-boggling. Stay tuned for our next video, where we'll explore more remarkable military marvels. Don't forget to like, subscribe, and hit that notification bell so you never miss out on the latest in military technology. Thanks for watching.